Hi, welcome to my video on relations among trig functions, and this video is on the Pythagorean relations. Let's look at a unit circle, and a unit circle has a radius of 1, and we're going to have the center of the circle 0, 0. So the center is 0, 0, and the radius is 1. So that means this point here is x is 1, y is 0, and we're going to look at a point on the circle. So this point is on the circle. The rotation here is theta. The terminal arm passes through this point. We drop a perpendicular to the x-axis. So this rotation of theta, so the reference angle is equal to the value of theta. And this is the x value, and this is the y value, and the hypotenuse is 1. And what we have, because we have a right triangle, we have c squared equals a squared plus b squared. So the hypotenuse is 1, and a is x, and b is y. So we have x squared plus y squared equals 1 on the unit circle, whose radius is 1. But we also know that the cos of theta, this is theta, reference angle, cos is the adjacent over hypotenuse, so it's x over 1 or x. And the sine of theta is the opposite over the hypotenuse, which is y over 1, opposite over hypotenuse, which is the y. So we can do a substitution. So if x is cos theta, x squared is cos theta squared, and y squared, y is sine theta, so that's the sine of theta being squared equals 1. So we subbed the x, replace x with cos theta, replace y with sine theta. So notice I have the square here, but this is written down as the cos squared of theta plus the sine squared of theta equals 1. So cos theta all squared is also written down like cos of square theta, cos squared theta. And this is the identity that we're going to use, and it's the fundamental identity in trig. Now let's look at a circle whose center is still 0, 0, and a point on the circle is, we take the point on this circle to be 3, 4. So let's take this point here to be 3, 4. So if this is the center of the circle and this is the rotation to get, so there's the terminal arm passing through this point. So this is the rotation. So this is the value of theta. So the terminal arm passes through this point. So theta is the rotation. Drop a perpendicular to the x-axis. And this is the reference angle. So we have this point. So we have x is 3, y is 4, and we have a radius. So what we have is c squared is a squared plus b squared. The radius is the hypotenuse, so r squared is 3 squared plus 4 squared. So r squared is 9 plus 16. R squared is 25. R is plus or minus the square root of 25. So r is plus or minus 5. But the radius of the circle is 5. So this is a 5 here. So the theta is the angle of rotation here, and this angle is the same as the reference angle. So the triangle has the sides of 3, 4, and 5. So if c squared equals a squared plus b squared, then what happens is that the cos of theta is cos is adjacent over hypotenuse, which is 3/5. So cos squared is 3/5 squared, and that gives us 9/25. And the sine of theta, sine is opposite over hypotenuse, which is 4/5. Sine is opposite over hypotenuse, and so we take the sine and square it. So it's 4/5 squared is 16/25. So if we take cos squared and add on sine squared, we have 9/25, add on 16/25. So that means that cos squared plus sine squared, both denominators are the same, so we add 9 plus 16 is 25, and that gives us a 1. So cos squared theta plus sine squared theta is equal to 1. Again, the fundamental identity. Now, there's, even though this is the fundamental identity, coming out of this, cos squared could also be 1 minus sine squared. Take the sine squared and move over here, make it a minus. And another name for that, this is the difference of two squares, so this could be factored also. 1 plus minus sine theta. So the difference of two squares. So it's 1 squared and cos theta squared. And also another name coming out of this, that sine squared is equal to 1 minus cos squared. And again, the sine squared, this is the difference of two squares, so this is 1 plus cos theta, 1 minus cos theta. So keep in mind the fundamental identity, cos squared plus sine squared is 1, and cos squared is 1 minus sine squared, which could also be factored. And this is, you need to know this when we do identities in trig. And so sine squared is 1 minus cos squared, and which is 1 plus sine, 1 minus sine. And you'll know, or you'll learn how to do the identities using these properties. And that was done in trig 1. Also, coming out of that, the fundamental identity of trig, which is cos squared theta plus sine squared theta equals 1, the fundamental identity has a circle, and again, the circle has a center of 0, 0, and has a radius of 1. But that's if it's a unit circle, but this works on any circle whose center is 0, 0, and whose radius could be any value. So not only has to be a unit circle whose radius is 1, center 0, 0, but we could have the center 0, 0, and any radius that would make this true. So in relation to this fundamental identity, let's take this fundamental identity and divide each part of the equation by cos squared. There we are. So cos squared, each divided by cos squared divided by cos squared is 1. And tan squared divided by sine squared divided by cos squared is the same as tan squared, because tan is sine over cos. And 1 over cos is the reciprocal of 1 over cos is secant squared. So, out of the fundamental identity, by dividing by cos, we would have 1 plus tan squared is secant squared. And we could also have it coming out of that 1 is equal to secant squared minus tan squared. So if you know these, if you see 1 plus tan squared, you can automatically replace it with secant squared. Or if you have another name for 1, 1 could be secant squared minus tan squared. Again, memorize these because they'll be needed when we do identities. And also the fundamental identity of trig, which is this, cos squared plus sine squared equals 1. Now, if we divide each part of the equation, or each side or each part of the equation by sine squared, it makes it true. So cos squared over sine squared, that's the same as cot. Tan is sine over cos. Cot is cos over sine, reciprocal. Sine divided by sine is 1, and 1 over sine is cosecant squared. And how I know, if you got a C, you have an S. If you have an S, you have a C. So the reciprocal of sine is cosecant. The reciprocal of cos is secant. CS, SC. And again, another name here is that cot squared minus cot squared theta minus, let's not go that way. Let's leave the 1 there and go cosecant squared minus cot equals 1. If I was moving this over here, I would get a negative 1, which would be true. So 1 is equal to cosecant minus cot. Cot goes to the other side. So these are a couple of more identities. 1 plus tan squared is secant squared, or 1 plus cot squared is cosecant squared. And how do I know which is which? So 1 plus tan squared, why is it secant? Well, tan is sine over cos. Because cos is in your denominator, that's why I know it's secant, because that's a cos, reciprocal is secant. And right here, we got cot. Cot got sine on the bottom, and the reciprocal of sine is cosecant. And that's how I know 1 plus tan is secant, again, because cos is on the bottom, reciprocal is secant. And in cot, sine is on the bottom, its reciprocal is cosecant. That's how I memorized it when I was doing all the math in calculus, in high school, in university, wherever. So that brings us to the end of the fundamental identity and the couple of more identities from there. Again, if you like my video, click on the like button, click on the subscribe button if you wish. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.